if you were working on last night's homework. Remember, once again, we are in Chapter 8. We are talking about matrices in some way, shape, or form. This was the problem we ended with yesterday. However, homework got up to numbers like 29 and then up to like the 30s and the beginning of the 40s. And they were talking about these things called row operations. So I stole an example really quickly that maybe you had in homework, but I don't think you did. That we started off class today, and I had you do some searching around in your calculators, etc. But you were supposed to, in some of those problems in homework, fill in the blanks in the sense of what's missing. This one is the original matrix in the sense of your starting matrix. And something was changed between the first and the second and the third, and all of that, these row operations. You're trying to identify the row operations. The book calls them elementary row operations, right? Technically. Not as in elementary school. Don't worry, not like that. But let's zoom in really quickly on what we did yesterday to review what on earth are row operations. All we talked about yesterday is row echelon form and RREF, reduced row echelon form. Oh, wait a minute. Hold on. Who are rows? Because I said things about multiplying rows, right, by something. We did R1 and R2 and R3. Well, didn't have to do R3 yesterday. What do we label R1 and R2, guys? Quick recap. What do we label R1 and R2? Who is R1? Yeah, it's like equation 1, last chapter, and this chapter it's row 1 of the matrix. And R2, when we talk about him, we're talking about the second equation's relationships, or R2 of our matrix. Now, every time we refer to, as we go down through these steps, and we change the matrix a little bit at a time, if I refer to R1, I'm referring to the previous R1, because we're changing it to be a new R1. So then when we go to the next matrix, we're using the old R1 and the old R2. And so every time they're kind of changing, they're kind of transforming. But at the very end of the day, we still have an equation on top and an equation on bottom that we could technically go ahead and go from the matrix to an equation of 1x, because this was the x column, plus 0y, which is why we don't really write it, equals 1/2, which is why I said, hey, we solved the system by going to RREF. Or the second row would be 0x plus 1y equals -3/4, which is why I knew y equaled -3/4. And we had already solved this yesterday with substitution. Or did we do elimination? What did we do? We did substitution, I think. Oh, here it is. Remember we covered it, or we solved it really quickly off to the side, because I'm like, well, in chapter 7, we wouldn't have done this crazy matrix stuff, but we're doing easier examples using matrices to build up to harder problems. Now, how did I go from this original one yesterday all the way down to, hey, look, answers, 1/2 and -3/4. 1/2 and -3/4, rows and columns. But maybe not rows and columns. Actually, we were working by columns. And every time we got to a column, we would first do what? Well, that's what we would do, but what was our purpose? What were we wanting to get? The 1. We got the 1 first in a column, and then after we got the 1, what did we go trying to get? The 0. And then when we move to a new column, then we say, okay, let's get the 1, and then let's get the 0. So we were getting 1s and 0s, and here's the dealio, guys. These are row operations. Now, they're not the only row operations. Does anybody have a light-up screen calculator real quick? That's really close to me? Thanks. Matthew. Thank you. If I, that's way too zoomed in. Okay. If I was to do what I had you guys do, which was, let's see, go to the second x to the -1 menu, right? And then put in a matrix, which should have put you here at edit, right? And then you would have had a 2 by 3 if you had put in our original matrix, which was from yesterday. 8, negative 4, 7, 5, 2, 1. Thank you, Matthew, for doing that. And you have that all in, ready to go. Then I had you guys review how you need to get out of that menu to the home screen. You can go back to that second x to the negative 1 math button. Where's that RREF again? Down here somewhere, right? There we go, RREF. Then going second x to the negative 1. Name is how we steal a matrix so that we can use it or we can do operations to it. That's how you could get, oh, ew, decimals. Hey, what did I show you yesterday? Math, fraction. We can go to fraction and say, oh, yay. Well, that's cool. So our calculator has this all programmed in, going from a matrix, an original matrix, which is stored here in A, and how to get ones and zeros and then our answers off to the side. We have to say x equals y equals, but otherwise it's like, oh, sweet, that's a whole system of equations solved. But do you guys notice what was right below the RREF? Oh, sorry, I meant second matrix math. What are these guys? Row, swap, row, add, multiply, row, add. Guess what your row operations are? These. You can swap rows. You can add rows together. You can multiply a whole row by a number, or you can multiply a whole row by a number and add. Now, to be honest, to figure these operations out would probably be a bit harder than just figuring out how to do it by hand. But some of you guys, the numeric mental math is going to maybe lose you just a little bit, which is why I showed yesterday. When we needed to get a 1 and we had an 8, I gave a hint as far as doing it by hand as to what you should do. Anytime we want to get a 1 and we have a number, we should always divide, like Joe said, or I say multiply by the reciprocal. But a row operation must be done to the entire row, which is why 8 over 8 was 1, negative 4 over 8 was 1, negative 1/2, and 7 over 8 was 7/8. Whenever we do a row operation, we have to do it to the entire row. Hold on, Joe, let me finish my thought. And if we want to get zeros, what's my hint? Well, we are going to be adding, but what do we have to do before then? We have to get a 0, and if we're adding to 5, what do I have to add to 5 to get rid of it? A negative 5. So I'm going to multiply this row by the opposite value, by negative 5, which you see right here. I'm multiplying row 1 by negative 5 by the opposite number in our 0 spot, and then adding it. So negative 5 times 1 plus 5 is 0. But I have to do that all the way across the row, multiplying every entry by negative 5, and then adding every entry to its corresponding entry. So if that math is too much, you can come off to the side, and you can take every single entry and multiply by negative 5. Take all of row 2, and you can do it off to the side and get your values and then put them in. So if the mental math is too much when we're doing row operations, you can do a little bit of work off to the side. Now, Joe, what was your question, buddy? No, that's illegal. It's like saying if you have a whole equation, can you just double that term and not the rest? What you do to one side, you have to do to the other to keep an equation balanced. No. No, it's illegal. Okay, so as we're looking here, what do you guys notice? What did you notice that changed from this matrix to that matrix? Row 1. Row 2 and 3 were exactly the same. Nothing changed. So what changed in row 1? The 2 became a... Oh, so if you're doing the legal row operation, you would have divided everything by 2. So what happens if I multiply row 1 by a half? The 2 becomes a 1, the 4 becomes a... Does that make sense? Following the legal row operation, following the advised row operation. Now, there could have been other ways to do it, but the legal row operation, the advised row operation, how to get a 1, this is what the book would have expected you to do. This is what I would expect you to do now that we've reviewed. Oh, to get a 1, we always divide. But what changed from here to here? They finished the column and got their zeros. So row 1 didn't change at all. Oh, did you guys just use the 2 and the 4 and the 3 halves? Nice. But do you see why they're there? But now we have to figure out, okay, well now we're kind of stuck. There's no next step that shows us what goes there. So we just said multiply by the opposite and add. Wait, well what was in this spot? So then we needed to multiply this row, row 1, by something that would cancel out the positive one. So I'm going to do negative 1. Negative 1, row 1, plus row 2. Or if it's easier in your mind, you can think row 2 minus row 1. What's 1 minus 1? 0. What's negative 1 minus 2? Negative 3 minus 4 is negative 7. We got it. 2 minus 1½ is 1/2. Or 2 minus 3 halves. 4 halves minus 3 halves is 1/2. So who, bold, courageous soul, is willing to raise a hand and tell me the row operation or the equation to get row 3? The row equation to get row 3. Matthew. No, not divide by 2. Keep thinking. Not divide by 2. Not multiply. That's to get a 1. We're getting a 0. To get 1s, we multiply by the reciprocal, or we divide. To get zeros, remember, real quick, to get zeros, we want to add the opposite. And so we take wherever our established 1 is, whatever row that is, multiply it by the opposite coefficient, and then add. So how would that translate to this example? What is our row operation, Joe? No, that's not going to work, because 2 minus 1 is 1. Oh, we don't skip earlier in the matrices, buddy. We don't skip earlier in the matrices. But that was a good idea. He was like 2 minus 2. That works. But our row 1 was changed. Our row 1 was changed. This is the new row 1, row 2, row 3. How do we use the new row 1? Row 2 minus row 1 gets that, but that's what we already did. We need to change row 3. Yeah. We can do row 3 minus 2 row 1, or you can think negative 2, the opposite, times row 1, plus row 3. The opposite of what's currently there times the first row, plus row 3. Now for my mental mathers, you're like, that's a lot of math. My non-mental mathers, I should say. That's a lot of math. I need to multiply this whole guy by negative 2. You could do this off to the side. So you could say negative 2r1 plus r3. You could actually set this up. You can say, okay, if I multiply r1 by negative 2, that'd be 1 negative 4 times negative 2, and 3 halves times negative 2. The 2's actually cancel. You just have the negative. Row 3, all I have to do is rewrite it. So 2, 6, 4, 9. If it's too much mental math, you can just come off to the side and set up the little baby formula that you're trying to plug in. And then you can get 0, 2, negative 4, 6, which is what would fill in. My mental mathers, you can just say, hey, I can look at row 1 and say, negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 2 is negative 4 plus 6 is 2. Negative 2 times 4 is negative 8 plus 4 is negative 4. And negative 2 times 3 halves is negative 3 plus 9 is 6. Either way, you get the exact same answers, and you're just as right. How do we get 1s? Divide or multiply by the reciprocal. How do we get zeros? Take the row with the 1 you just got, multiply it by the opposite of whatever's in the spot you're trying to get rid of, and then add. Boom, boom, done. What are we doing? I'm helping you guys with the vocab of the homework as far as that wording, what to do when it talks about row operations, doing addition to rows or multiplication of rows. I'm reviewing what our process was, what our procedure was as far as getting ones and zeros for the purpose of solving a system of equations to get and to solve a system as far as for the unknowns that we have. Because here at the very beginning of notes yesterday, we said, okay, why is this book starting matrices in such a difficult way? Because chapter 7 had us solving what? Systems ending in row echelon form. With substitution, elimination, row echelon form. Row echelon form was with equations, back substitution. But now it's like we can actually do that with matrices. Take out all the x's and the y's and the z's. Take out all the wording of eliminate x, row 1, row 2. Eliminate x, row 2, row 3. Eliminate y, row 4, row 5. Eliminate to z. Then back substitute, z up, and then z and y up. That was row echelon form from section 7.3. Matrices say, whoa, 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 whoa. We can make this so much more organized and in a way that a computer program can understand. So we're going to tackle this guy. We're going to tackle this guy. Some of you guys might have even gotten to some other new vocab and homework last night called augmented matrices. Some of you might have gotten to that and been like, what? Augmented matrices are just the snazzy name for, and maybe I should even put it off to the side. This whole thing is an augmented matrix. It's RREF. That's what we're going to do. We're going to get down to ones and zeros in our answers, hopefully, of a 3-variable system that we could have solved with section 7.3 using our system, that some of you totally remembered for the test and some of you didn't, of eliminating the x with R1 and R2, with R2 and R3. Then eliminating the y with R4 and R5. And then writing our 3-variable system with a 1x and lots of stuff, and then a 1y and lots of stuff, and then a 1z, if it all worked out. Then back substituting. This is how section 7.3 would have said to do this. And it works. It is a system. But we have to write all sorts of x's and y's and z's and showing all of our work, and matrices actually makes it a lot shorter and sweeter. Oops. So real quick, this page, the process isn't the augmented matrix. The augmented matrix is just the vocab for how to go from a system to a matrix. That's all it is. So in homework, when it says write an augmented matrix, all you have to do is be like, hey, you can look like this in matrix notation. Basically, pull out all the constants. But if there's something missing, what do you need to put? A 0, just like we do in long division or synthetic division. Or when trying to match up terms in something like a partial fraction decomposition. If there's something missing, put a 0. But otherwise, basically, an augmented matrix says, hey, organize all your info, which in these homework problems, it was kind of nice. They gave you the x's, the y's, the z's, and other problems that might be mixed up. So basically, get all of your variables on one side, get them all nice and organized as far as by columns, the x column, y column, z column. Your constants or your solutions will go over here. Once again, if this was like all mixed up in a word problem or something, they told you x is equal to 4y minus 3z plus 5, you would have to like move everything to one side. You can use a dotted line or a solid line, either way. But augmented just means take that, put it into that. Sweet. Now we're going to try to solve the system with matrices using RREF going all the way straight to the answer. Now, I know you guys can plug it in your calculator. If you want to, you can use that to keep me honest. But we are going to go by hand, step by step, because remember, I said part of this test, calculator. Part of this test, non-calculator. Here we go. So R1, R2, ooh, sorry, you can't even see it. Struggle. We're going to work by columns, getting ones and zeros. Work by columns, getting ones and zeros. Hey, Go, team. What's already in row 1? Sweet, we don't have to get a 1. All we have to do is get zeros. So I'm going to go ahead and rewrite row 1 because he's totally fine the way he is. I have my 1 right where I want him for column 1, but now I need zeros. Do you remember what we said? I have to add something to row 2 to get row 2 what I want it to be. I have to add something to row 3 to get it to be what I want it to be. I'm using R1. Check it. There's such a system. There's such a system. What's the opposite of -1? No? Yeah, the opposite of -1 is +1. Sweet. What's the opposite of +2? There you go. Just do the opposite. The opposite of where the 1 is plus whatever row you're trying to change. But be careful. You have to do it to every single one. Now, could you come off to the side and could you have a scratch whiteboard or a scratch piece of paper and write out 1 times R1 plus R2 and actually do elimination? Yeah. But maybe some mental mathers. You can track with me when I say, oh, it's just R1 plus R2. Sweet. What's 1 plus -1? Move over. What's -4 plus 3? 3 minus 1. 5 minus 3. Why? Because I was following my row operation. But it's not going to be quite as easy in the next one because the next one I have to multiply every entry in row 1 by -2. So once again, you could go off to the side. What's -2 R1? And you could actually write it. What's R3? You could actually write it. And you could do your little system of equations in the sense of an elimination. Or, mental mathers, -2 times 1 is -2 plus 2, 0. But I have to do this little baby row operation to every single set of corresponding entries. So now it's time for him. And it helps my mind if I'm trying to do it mental math by pointing. So -2 times -4 is 8, right? -2 times -4 is 8 plus 0. 8. -2 times 3 plus -4. -2 times 5 plus 6. Now, pause. If you're like, okay. Okay. Then just admit it to yourself that you're going to have a little baby side whiteboard, a little baby side scratch a piece of paper, and be like, okay, it is what it is, and it's totally fine. There's no shame in getting it right your own way. So you could write this little row operation off to the side and say, okay, I'm going to multiply everybody by a -2. It's -2, 8, -6, -10. I'm going to rewrite row 3. 2, 0, -4, 6. Ha! 0. Ha! 8. Ha! -10. Ha! -4. Boom, 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 boom. I got 'em. You do what you need to do. Okay? Cool. I'm not going to do any more side work. I'm just going to go for it mental math style. You guys ready? Column 1, done. Column 2, it's time. Let's go aim for that 1. Wait, why am I going there? Because the 1s need to go down the main diagonal. So I'm going to divide, because we always divide, or multiply by the reciprocal, row 2. So it's really just 1 over -1, but whatever, it's times -1, right? So row 1 doesn't change, because I'm not allowed to go for my zeros yet. Row 3 doesn't change. I'm not allowed to go for my zeros yet in column 2. But row 2 is going to change. The nice thing is, if you do this in its proper order, if you do it in another order, you'll mess it up. But if you do it in its proper order, 0 times anything is going to stay 0 just like I need him to stay. -1 times -1 or divided by -1 is a +1. 2 divided by a negative. 2 divided by a negative. I have my 1. Now what? Go get your zeros. Let me give you a second to try to write out how to get your zeros. Can you write out the row operations in row 1 and row 2? Row 3, huh? In row 3 and in row 1 are where we need our zeros. I'm going to rewrite row 2 just because it stays the same. It's where my 1 resides. It remains the same. you guys remember your adding? You're adding to cancel. Do you guys remember you're multiplying by the row with the 1 to add to cancel? You're multiplying by the row with the 1, which is row 2. You're multiplying by the row with the 1 to add to cancel. And the only way to add to cancel is to multiply the 1 by the opposite. Pause, reflect, questions. To get the 1 is kind of easy. Most of our brains are like, oh yeah, divide by, it's 1, got it. To get the zeros are a bit harder. I'm adding to cancel. But to add to cancel the -4, to add to cancel the 8, I need a +4. The easiest way to get it is take this 1, which is in row 2, multiply by the opposite. The easiest way to cancel without messing up any of this is to take the row with the 1 and multiply by the opposite. Yeah. We had a row 1, and it was good for column 1. But now we're moving on to column 2, because at the very end of the day we want 1x equals 0, 0. 1y equals 0. And 1z equals. We want a 1, 1, 1, the rest zeros. Does that kind of make sense? And so that one, row 1, was good. But once we moved over here, we got the 1. Now we're going for zeros in order to get our RREF form. So we had a row 1, and we actually had a row 1, we had a row 1. So every time row 1 is kind of morphing. Sometimes he's staying the same, but sometimes it's his turn to change again. Tyler? Mm-hmm. So getting the 1, getting the zeros was establishing column 1. Good. Then we said, now it's your turn. Get the 1, get the zeros. Good. Hopefully good right here. And then column 3, get the 1, get the zeros. Does this work? I have to start each entry. I'm pointing to row 2 times 4. What's 4 times 0? Plus 1. Perfect. I wanted that 1 to stay. 4 times 1? Minus 4. 4 times -2? Plus 3. And 4 times -2? Plus 5. Now I know I get to do the pointing and you get to do the thinking. When you're doing it, you're going to have to do the pointing and the thinking yourself. So try to get me row number 3. Try to get me row number 3. And if you can on your paper, it might be nice to point and do your own mental math. If you need to, you can take this little formula off to the side and write them out. And that works too. Anybody get 0, 0, 6, and 12? More. Mm-hmm. But not tons, because as you can tell. Yeah, and to be honest, from all of chapter 8, this process is the longest type of problem. as far as by hand work, which is weird. It's section 8.1. It gets easier in section 8.2. Let's add matrices. Let's multiply them. Let's subtract them. Let's do some nice things from Algebra 2. So hang in there. Column 1, done. Column 2, done. Column 3. Ooh. Let's get our, we have to get our 1 first. Oh, wait, hold on. But have you guys gotten it by yet? Or by yet? By now? We get to rewrite row 1, because he stays the same. We're not working with him. Rewrite row 2. We're not working with him. But who are we working with? Row 3. We're getting a 1. How do we always get 1s? Get the system down. You don't have to be creative. How do you get a 1? Divide. Or multiply by the reciprocal. You see it? If some of you guys want to think about it, technically this is 0x plus 0y plus 6z is 12. Of course you divide by 6 to get 1z. Divide by 6, divide by 6, there's still 0. Divide by 6, 1. Divide by 6, it's 2. Dun, dun. Now it's time to get my zeros. Rewrite row 3. He's good. Some of you can taste the victory. We're right there. We need to change row 1, change row 2. Change by adding the opposite, positive 5 times, positive 2 times. By adding the opposite obtained by multiplying the opposite by my row with the 1. Ha-ha. The nice thing is, if you've done this correctly, this multiplication will be times a 0 plus, which will just keep it the same. Times a 0 plus, which will keep it the same. Now times a 1. 5 times 1 minus 5 is 0. 5 times 2 is 10. Minus 3 is 7. I just got my 1x is 7. 2 times 0 plus should keep it the same. 2 times 0 plus should keep it the same. 2 times 1 minus 2. And 2 times 2 is 4 minus 2 is 2. If you guys did RREF in your calculators, you should have gotten the identity matrix, 1, 1, 1, zeros everywhere else, with a 7, a 2, and a 2, which means, remember, this is the x column, this is the y column, this is the z column. You end up with x equals 7, y equals 2, and z equals 2. Hence the 0.722. What if you were to ever try to do RREF in your calculator and it said, yay, yay, zeros? Was there ever anything in section 7.3 where the z part, the bottom part, just disappeared? Oh. Could there be a z equals a that shows back up? And how would it show back up? Your poor calculator has no idea what to do besides I went as far as I could and the bottom row is just 0, 0, 0, 0, 0. I'm confused. Sorry, there were way too many zeros. So what would you have to do if the bottom row ever became 0, 0, 0, 0? Let z equal a. And then you could make a little back substitution equation going from the augmented matrix to the system of equations and solving that way. Guys, this homework isn't due until Thursday. Tomorrow, what's going on? I'm not going to be here. A sub is going to be here. My advice is for you, if you have your books, to bring them. If you don't, grab it at the very beginning of class before the bell rings. Don't make the sub let you get up, and that's annoying. Have a book at your desk. Have your 8.1 homework in your homework spiral. I'll probably play an example or two up there for you guys to, because there is a further example or two that I did last year, like if I was here that I would do. But you guys can be working on homework the whole time, but be listening to any further examples as far as tricks you might get caught on. Sound good? All right. Bring in your books tomorrow. Work on your homework in class. If there's extra time, you guys can work in your groups productively. Bye, guys.